let's have a quick discussion about box plots, outliers, and when we should use the mean and when we should use the median to analyse data. If we look at this first box plot here, remember this represents the lowest value, this represents the highest value, this is our lower quartile, our median, and our upper quartile. Looking at this box plot here, it's almost exactly symmetrical. If it's symmetrical, let's say that we have a median of 50, then you would expect the mean to also be about the same. Okay, symmetrical data, the middle is about there, and you have as much data below as above, and they're spread equally. So the ones which are below are about as far below the mean as the ones which are above. This we would say has no skew. The mean and median are approximately the same, and the box plot looks equally distributed. In this case, we would use the mean to analyse our data, as it's not being thrown up or down by any extremely large or extremely small values. The mean is a good measure as it does consider all of your data, whereas the median and the quartiles disregard large chunks of your data. Okay, what about this second case? In this second case, we have a much lower quartile and median, and then the gap to our third quartile is somewhat larger. Okay, and then we have this cross out here, which actually represents an outlier, a value which is deemed to be too large for some reason. Perhaps when we look at the data, it just appears unreasonably high. Maybe this is a collection of temperatures, average daily temperatures in, say, Camborne, and this one here is, let's say, 56. It's much more likely that that should read 5.6 than 56 degrees. So we'd class it as an outlier. It may be correct, maybe there was one exceptionally hot day in Camborne, however, it's likely to be an error, so we highlight that fact. In this case, because we have our main group of data down here, and then it starts to spread out the higher above the median we get, we would say this is positive skew. In this case, say we had a median of about 20, you would expect the mean to be somewhat higher than that, maybe something like 25, maybe 24. Okay, the main thing is it's higher. This outlier and this much higher range, the greater distance between the median and the upper quartile, is going to drag that mean up. The mean is going to be skewed by a few very large values. So when we talk about skew, we mean how has the mean been skewed? The median is exactly in the middle of the data. The mean has been pulled up. So we call that positive skew. In this case, we should use the median to measure our data because the mean has been skewed. In this case, we have almost the exact opposite. We have our Q1, Q2, and Q3. We now have two outliers down at the very low end, a very big gap between Q1 and Q2, and then half of our data bunched up in this tiny little section here. So in this case, maybe we've got a Q2 of something, a Q2 of something about 80. But if we look at this, we've got some extremely low data down here. That's going to pull down our mean, and therefore we would expect our mean to be somewhat lower, maybe 62. It's considerably low. We've got some very low outliers down here. Okay, we would call this negative skew. Remember, we always talk about how the mean has been pulled. Which direction has it been pulled in? In this case, it's been pulled towards the negative values. It's negative skew. The mean has been reduced. In this case also, we should use the median to analyse our data, as we know that our mean has been skewed by a few outliers.